Hello friends, welcome to our channel on Academic Education. We have been discussing mathematics basics and this is our third lecture. In the last two lectures we had seen number system and different kinds of intervals. And today in this lecture let us discuss modulus function. Modulus function. Modulus function, this is also called as absolute value function. Absolute value function. Absolute value function. So what is this modulus function or absolute value function? So this is a type of function that gives us absolute values. No matter what value or what number you give, the final output will be absolute or positive. The final output will always be positive. So modulus function is like a kind of machine. So this is a machine. This is a machine which gives always the positive outputs. So for example, if we give input as -3, then the output will be +3. Or if you give +3, the output will be +3. Or if you give -100 by 600, the output will be 100 by 600. So this modulus function will always give positive outputs. So this is represented as like this, mod x. So for example, if we take mod of -3, then the value will be 3. Or if we take mod 3, then the value will be 3. So no matter what value you take, the output will always be positive. No matter what value, whether you take a negative value or you take a positive value, the output will always be positive. This is absolute. So this is also called as absolute value. So this modulus function is a type of function that always gives positive values. It always gives us positive values. So this modulus function can also be considered as distance. With respect to origin. Can also be considered as distance with respect to origin. For example, if we say mod x is equal to 1, then this means that the distance covered is equal to 1 with respect to origin. So the distance covered, this is 1. The distance covered is 1. So as you know, distance is always positive. It cannot be negative. So it can either be in the forward direction, in the positive direction, or it can be in the negative direction. So this is -1. So this is origin, this is +1, this is -1. But this distance is 1. Distance is always positive. And here also it is positive 1. So modulus function can also be considered as distance with respect to origin. And as you know, the distance is always positive. Distance cannot be negative. So it is absolute value. Okay. Let us represent this modulus function in graphical form. So for instance, take f of x is equal to mod x. Then this is x when x is greater than or equal to 0, or minus x when x is less than 0. Please don't get confused with that. Um, because I am saying that the modulus function will always give positive output, then why is it minus x here? Because when x is less than 0, for example, let's take a number less than 0. Let us take minus 1. Let us take minus 1. Since modulus function always gives us positive outputs, then this becomes so minus of minus 1, which is plus 1. This is why when x is less than 0, mod x is equal to minus x. When x is less than 0, mod x is equal to minus x. So don't get confused with this negative sign and with the output of the modulus of x. Okay. So this minus x is because to give positive value. So when x is less than 0, so this is minus 1, which is less than 0. So minus of minus 1 is equal to 1. And that's why mod x is equal to minus x when x is less than 0. And when it is greater than or equal to 0, then it gives the same value x. But if it is less than 0, then modulus of x is equal to minus x. So now let us try to draw the graph of modulus function. So this is 0. This is 0. So when x is 1, 2, 3, 4, 5, and so on. Like this is y or f of x. This f of x also is considered as y. Okay, and likewise here it is minus 1, minus 2, minus 3, and so on. Okay, so now when x is equal to 0, modulus of x is 0. When x is equal to 1, modulus of x is 1. This is 1, 2, 3, and so on. And likewise, this is minus 1, minus 2. Okay. So when x is 1, modulus of x is 1. When x is 2, modulus of x is 2. When x is 3, modulus of x is 3. When x is equal to 4, modulus of x is 4. So modulus of x when x is greater than 0 will always be x. So it is a straight line. That increases uniformly. Okay. Now let's come to the negative part of x. So when x is less than minus 1, modulus of x is equal to minus x. So now x is negative. So we have taken the value of x as negative. So it is minus 1. So when x is minus 1, modulus of x is equal to minus x. This implies minus of minus 1, that is equal to 1. So when x is equal to minus 1, modulus of x is 1. And let me write it here. So when x is equal to minus 2, modulus of x is equal to minus of minus 2. This is minus of minus x. So x is minus 2. So now it becomes 2. So when x is minus 2, the value is 2. Like when x is 3, it is 3. When x is 4, it is 4. So modulus of x on the left side looks like this. So modulus of x is a V-shaped curve. It always takes positive. It always gives us positive values. It can take any value, negative or positive, but the output will always be positive. So this is the graph of mod x. So to sum up all our points, modulus of x can take any value. It can take any value, negative or positive, but the output will always be positive. And mod x is equal to x when x is greater than or equal to 0, and mod x is equal to minus x when x is less than 0. So don't get confused with a negative sign and with the output of mod x. This negative sign is there only to make the output positive when the values that we take for x are negative. Okay, so and mod x, the graph of mod x is a V-shaped curve. It is always a V-shaped curve. Okay. Now let us find the solutions of the following. Mod x is equal to 1. Is this true or false? Is this true or false? This is true, isn't it? Mod x is equal to 1 is true. So what would be the solutions? What would be the solutions? I mean solutions then. Sorry. What would be the values of x? What would be the values of x? X can take -1 or x can take 1. Isn't it? X can take -1 or x can take 1. And the value, this value will always be 1. This value will always be 1. The output will always be 1. And mod x is equal to -1. Mod x is equal to -1. Is this true? Is this true that mod x is equal to -1? No, it is not. This is completely false because mod x gives us always positive output, but here it is negative. So this is false and it has no solution. No solution. Mod x is less than 1. Mod x is less than 1. Is this true? Yes, it is. Because the output here is positive. So mod x is less than 1. This implies that -1 less than x less than 1. This is our solution set. So mod x can be less than 1 only when x lies in between -1 and 1. Only when x lies between -1 and 1. -1, comma 1. This is open. Open interval -1, 1. And mod x less than -1. This is false because mod x can never be negative or can never be less than negative. It can never be less than any negative number. It can either be 0 or greater than 0. Mod x is greater than 1. Mod x is greater than 1. What would be the solution sets? Mod x is greater than 1 when x is greater than 1 or when x is less than -1. When x is less than -1. When x is less than -1, for example, when x is equal to -2, mod x is equal to 2, which is greater than 1. When x is equal to -3, mod of -3 is equal to 3, which is greater than 1. So mod x is greater than 1 when x is greater than 1 or when x is less than -1. And mod x is greater than -1. This is false. Mod x is greater than -1. Mod x is greater than -1. Sorry. This is not. Mod x is greater than -1. This is true because mod x is always greater than or equal to 0. The value of this absolute value function can be negative or can be greater than 0, and that's why this statement that mod x is greater than -1 is true, and the solution set will be all the real numbers. For any real number, all the real numbers, you can take 0. Mod of 0 is 0. 0 is greater than -1. Mod of 1 is 1, which is greater than -1. Mod of -1, which is 1, is greater than -1. So the solution set here will be all the real numbers. Now let us solve this. Mod x is greater than or equal to 0. So what would be the values of x for which mod x is greater than or equal to 0? Mod x is greater than or equal to 0. The answer would be x belongs to R. Because for all the real numbers, you can take any real number, negative, positive or 0, the value of mod x will be either 0 or greater than 0. And that's why the solution set here will be all the real numbers. Mod x greater than 0. So mod x is greater than 0. So what would be the solution set? Or what would be the values of x for which mod x is greater than 0? So the values would be x belongs to R minus set 0. X belongs to R minus set 0. Because modulus function is 0 only when x is 0. So for mod x to be greater than 0, then the value should be greater than 0, then the value of x should be greater than 0 or less than 0. Greater than 0 or less than 0. So for all these values, mod x is greater than 0. So all these values will lie in the real number set. So we can say the solution set is all the real numbers minus set 0. So if we take minus 0.1 is greater than 0, or we can take minus 0.1. So modulus of minus 0.1 is 0.1, which is greater than 0. So the solution set will be all the real numbers minus set 0. So now let us look at some results that this modulus function satisfies. So the first is, if x belongs to R, or for all x belongs to R, x square is equal to mod x square. X square is equal to mod x square for all x belongs to R. Also, root of x square is equal to mod x, root of x square, because this is plus or minus x, which is nothing but mod x. So root of x square is equal to mod x for all x belongs to R. And the third one, mod x plus or minus y is less than or equal to mod x plus mod y. Mod x plus or minus y will always be less than mod x plus mod y. For example, let's take 2 plus 3, mod 2 plus 3. So mod 2 plus 3 is mod 5. Mod 2 plus mod 3. So this is equal to 3. Correct. Now let's take mod 2 minus 3. Which is equal to mod 2 plus mod of minus 3. This is minus 1, this is 2, and this is 3, which is 5. So 1 is less than or equal to 5. True. That's why mod x plus or minus y will always be less than or equal to mod x plus mod y. So these results will be very useful for us to solve the problems in the examination easily. So we need to remember these results in order to solve the questions easily. Let me have this. And the fourth result, mod x plus or minus y will always be greater than or equal to mod of mod x minus mod y. Mod of mod x minus mod y. So this mod is for the value mod x minus mod y. Now the fifth result. If mod x is less than or equal to a, then this implies that minus a less than or is equal to x less than or is equal to a. And a should be greater than 0. A should always be greater than 0. Okay, because mod cannot be less than a negative numbers. And now if mod x is greater than or is equal to a, then this implies that x is less than or is equal to a, or x is less than or greater than or is equal to a. And if mod x is less than a, then this implies that minus a is less than x less than a. This is nothing. We just remove the equal to sign here. We just remove the equal to sign here, and this becomes this. Okay. So when mod x is less than or is equal to a, then x lies in between minus a and a. And if mod x is greater than or is equal to a, then x is less than a, or x is greater than or equal to a. X is less than or equal to a, or x is greater than or equal to a. And now let's solve this problem. Mod x minus 1 less than or is equal to 2. Mod x minus 1 less than or is equal to 2. So we can use this result. We know if mod x is less than or is equal to a, then this implies that minus a less than or is equal to x less than or is equal to a. So this implies that minus 2 less than or is equal to x minus 1 less than or is equal to 2. So now this becomes, let us add 1 on both sides. Minus 2 plus 1 less than or is equal to x minus 1 plus 1 less than or is equal to 2 plus 1. This implies minus 1 less than or is equal to x less than or is equal to 3. So this is our solution set. These are the values of x for which a mod of x minus 1 is less than or is equal to a. So we can write this as x belongs to closed interval minus 1 comma 3. So mod x minus 1 will be less than or equal to 2 when x belongs to minus 1, 3, or for the values that lie in between minus 1 and 3. Now let us solve this. Mod 2 by x minus 4 is greater than 1. So we can write this as mod 2 by mod x minus 4 greater than 1. And this is also another result that mod a by b is equal to mod a by mod b. So we wrote this. So mod 2 is 2 and mod x minus 4 greater than 1. So this becomes 2 greater than mod x minus 4. 2 is greater than mod x minus 4, or we can write this as mod x minus 4 is less than 2. Mod x minus 4 is less than 2. So this implies that minus 2 less than x minus 4 less than 2. Because mod x minus 4 can be less than 2 only when x minus 4 lies in between minus 2 and 2. Now if we add 4 on both sides, minus 2 plus 4 less than x minus 4 plus 4 less than 2 plus 4. This implies 2 less than x less than 6. 2 less than x less than 6. This can be written as x belongs to 2 comma 6. 2 comma 6. This is open interval. This means that the values 2 and 6 are excluded. So mod 2 by x minus 4 will be greater than 1 only when x lies between 2 and 6. X lies between 2 and 6. So likewise, we can solve all the problems of modulus functions. And another thing is that x should not be equal to 4. X should not be equal to 4. So the solution set is x belongs to 2 comma 6 minus 4, because it is given here that x should not be equal to 4, because when x is equal to 4, then 2 by 0, this becomes infinite, and that's why, so it is given here that x is not equal to 4. So we need to look at the given conditions, given initial conditions also when writing the solution set of the given inequality or equation. Alright, so this is it for this lecture, and in the next lecture we'll come up with another